Hey, hello, everybody, and welcome to Show and Tell. I'm this week's guest host, John Park. Thank you so much for coming to see the show and all of the great stuff that people have brought on, projects and other things to discuss. If you want to hang out in the chat, you can head on over to Discord. That's adafruit.it/Discord. Jump into the live broadcast chat channel, and you'll find people discussing tonight's Show and Tell and beyond. And also there's a link there if you want to jump in and you've got something to show and a couple minutes to talk about it, then stop on by. We have a great group of people. We'll each try to take a couple minutes to show and tell our project, and then we will be able to finish up in time for Ask an Engineer that will be happening at 8 o'clock Eastern time. So we will get started first of all with Travis coming to us from DigiKey. Hey, Travis.
Hey, JP. So
what have you got to show us today?
So what I did was I created a MacroPad, and I don't know if the colors will focus there, with the Pimoroni Pico RPG keypad. And I have it currently set up for Onshape. And if you can share my screen, I can kind of show you here what we can do. Let's see if I can focus over here. So with the keypad, the green buttons here are all set up for directional. So I can do, I can rotate left, right, up, down. And then if you press the center button here, it actually changes color, but the camera's not catching it. It actually goes to a pan mode, so you can move it around.
Oh, nice.
And then these blue buttons here, the top one, it snaps to a front view. Middle is a top view, and then the bottom is an isometric view. And then the purple buttons down here in the corner, the left one is, it actually starts a new sketch. So if I click the sketch plane here, and then if I am in the line tool, start drawing a line, if I press the orange button, it actually changes that line to a construction line, and then you can toggle it back to a regular line as well. The second purple button here, that is for, try that again. If it wants to cooperate here, can start a new extrude. And then the last button, if I select normal things, it deselects everything.
So, oh, that's great. So you've really made your own highly customized version of sort of a space mouse, for the modern era.
Exactly. And that was kind of my thought behind it, is I've always wanted a space mouse for CAD programs, and I thought, why not? I have this hardware, might as well try and make it into it.
And what was the, how did you code that? What's that written in?
So it is all in CircuitPython, uses the Adafruit HID libraries for to emulate the keyboard controls. And one thing I'm looking to do is port it over so it can be used with Fusion 360 as well. And for that, I have to emulate a mouse command, so I'll have to use the HID mouse library as well.
Right. Oh, so some of the in Fusion 360, some of the screen motions have to be mouse and aren't HID keyboard.
Yeah. For Zoom itself, it's actually a center mouse button command, so it's a little bit different than your.
Or is that the mouse? Does the mouse wheel have its own? Is it a mouse wheel command that it gets, or just the click and hold and drag kind of thing?
It's a click and hold and drag command. Yeah. So the scroll is, I think it's that itself is it a pan? I think it pans the device around the screen. It's a little bit different than Onshape, so it's taking me a little bit longer to get that one done.
It's also impossible to know without doing it. I think even if you've used a 3D program forever and ever, you kind of have to like just grab a mouse and a keyboard, even if it's not connected to anything, and suddenly it comes to you. But like trying to actually describe some of these is nearly impossible to remember, I find.
Yeah.
Great. And did you have a project page or anything you wanted to show for this build or anything related?
Yeah, we do. I did a write-up for our maker.io page with including all the code and all the part numbers and everything used in there. So
Great. And people can find that, just head to the Maker.io main page.
Correct. It should be the latest project on there because it just went live today. So
great. Looks really cool. Thanks so much for joining us with that today, Travis. And come on back when you got it with Fusion and maybe on the MacroPad. We'd like to see it.
Sounds good. Thanks,
all right,
JP.
take care. All right. Let's see. Next up, just going in order of my screen here, we've got Liz.
Hello.
Hey, Liz.
How's it going?
Good, except have you heard there's a dog out there barking somewhere? That's I'm sure the mic is picking it up. So say hi to the dog. I don't know whose dog that actually is. Not my dog.
It sounds like a great dog. But I've got like it's not really a demo yet. It's more like a deep work in progress. But I'm gonna work on a robot lyre. So it's like a mini harp basically, and so the servos will strike the strings and respond to MIDI. So I had actually done a full hardware design using extruded aluminum that went across, and the servos were all mounted at an angle, but I had a really hard time getting them to be in the right position for the string because there is this like kind of curve you can see with the way that the strings are mounted. So I've gone back and I've been slowly redesigning it. So now I have this kind of bracket thing, and I just put it on top of a piece of acrylic right now with just some sticky tack to see if it would line up. And so now these servos are mounted directly above the strings. And then there's going to be this other bracket that goes on top. So it'll be like really held in place. And so I'm thinking then I'll have a larger 3D printed piece that will mount to the acrylic, and then I'll be able to kind of get into getting a good demo of this going.
So that'll sort of sandwich the...
Yeah, it'll be this kind of sandwich thing. Yeah. But with this right now, like they are directly above the strings, which is exciting. And I have code that when you press the MIDI keyboard button, like it recognizes what direction it just swiped in. So they each will independently kind of strike back and forth so that you're getting like the fastest possible.
Oh, so you'll remember the state
exactly
every note so that you can always... That's cool.
Yeah. So that's coming shortly. So I've been doing a lot of product guides recently. So basically I'll kind of spend most of the day on the product guide and then do like 2 hours on this. So slowly cooking in the background. Yeah, slowly cooking in the background. So hopefully maybe next week I can have some actual playing demo.
And it looks like you've done some sort of a custom horn for the servo and the yellow part there. What is this? Like a little...
so I can lift it up. So basically it's just a little like extension. And then I actually kind of drilled out the center of the horn so that it was an M2 slot so that I could really attach it nicely. Because that was the other thing with the other design I had. I was doing custom horns, but the strings were causing too much resistance against the horn, so it was getting out of whack. So that was another thing I learned the last time I attempted this. So hopefully this will keep them kind of in place.
Great. Well, good luck with that. That's really cool. I'm looking forward to hearing this thing get played. So thank you so much. And we will next up bring on Maker Melissa. Hello.
So I've been working on the CircuitPython.org website, and I've been working on an installer here. And so you can go onto it and it'll show you a menu. And I'm gonna, this is the ESP32 Huzzah that I'm doing it on. So I'm just gonna kind of go through the install. It just takes a few minutes here to kind of go through. But there. Sorry, I had a cat on my desk here. So it starts with going through with erasing the flash, and then it's going to go and write the binary file directly onto the chip, and that usually takes about a minute or so.
So is this a ESP32 specific?
Yes, ESP32, S2, S3, and I haven't tested the C3, but it should work.
I like that it's just kind of a wizard that guides you through the thing with very little interaction. I know I've used some of the other methods for install, and it's usually a little more involved.
Yeah, this one's especially interesting because it doesn't have the CircuitPy drive that shows up. And so normally you have to go in through the REPL and get it all set up, and there's a lot of steps to it. So I'm trying to make it as like simple as possible here.
Great.
So, getting close. So I actually have a pull request in for this, and hopefully this will be live soon. And hopefully this doesn't mess up here while on my demo here, because the anticipation. I had to put in a few things just for testing that are a little different than the pull request. Let's see.
And when you run this, do you place the board into bootloader mode with like a reset button? Nothing like that. You just plug it in and go.
Wow. Yeah. I'm trying to make it like as smooth as possible with this little interaction.
Yeah, I've reached the point where I can never remember which boards want a slow double press, a fast double press, the boot cell, and the reset. Like we have about 3 or 4 different ones that are.
So once it does that, then it kind of boots up with CircuitPython, and then we have to kind of select the drive again at this point, and then we want to put in the web workflow stuff. So let me go ahead and type in my stuff. I'm going to just leave the default password and port and just hit next. And then it just waits for an IP address. And then once it gets there, you can go right to here. And it will go ahead and load the code editor. So it just takes a moment.
There was a question in the chat from Guy about, is this Chrome only right now? Is it Chromium browser?
Yeah, like Chromium-based browsers is, but just because it uses some of the some of the APIs that are only available on some of those, like the file system API. So anyway, so I got the web workflow here, and so it's all connected and ready to go on there.
Great. So easy.
Yeah, that's what I'm going for.
Thank you so much for this. This is great. People are gonna love this. And your demo totally worked, which congratulations.
Yeah. I went through a lot of debugging today because just to check as smooth as possible.
Well worth it. Great.
Yeah.
All right. And so you said there's a pull request in for this at the moment?
There is, yeah. So hopefully that'll be live in the next few days.
Excellent. And for people who want to check it out, do we have any, is this integrated in any of the information right on circuitpy.org on the board page or in a guide, or is it just click it and it should be pretty self-evident?
I'm trying to go for more of the click and be self-evident, but I'm not sure if I'll end up writing a guide or not for it.
Right on. Well, good luck with that. Thank you so much, Melissa.
Yeah, thanks.
Okay, next up, we've got Jepler.
Good evening. So I published a guide this week. It's the first time I've done a product guide for Adafruit. And if you bring up my overhead camera, I'm sharing that. Yes, hooray. So this is the OV5640 breakout board. They're Adafruit's version, and it's plugged into a Kaluga dev kit here, which has the espressive. But in the guide, we also show hooking it up to an RP2040, and all of that is running CircuitPython code. This little demo here, I can switch it over to the live camera view, and it's okay responsively, pretty good for CircuitPython, I think. And yeah, we show how to save JPEGs, how to show on an LCD, and even just for fun, we've got an ASCII art version, so you can get a really lo-fi rendition of what's on the camera in a terminal on your computer. So
that's fun.
Yeah, check out that guide. It's listed up as one of the new ones. And if you've got a compatible board, which is the ESP32S2 or S3 or the Raspberry Pi Pico RP2040, you'll be able to use this camera with CircuitPython. I'm told you can do it in Arduino and C++ as well, but I don't know anything about that. We covered just CircuitPython in the guide.
And for RP2040s, is it the Pico only, or are there feathers that'll work?
It depends like on your available pins. So the actual Raspberry Pi Pico with all those pins broken out is the best. I haven't actually done the arithmetic to see whether you could do it on a feather. But yeah, and for that one, you have to do hand wiring. The reason we picked this board over an Adafruit board is it has this standard 2x9 header. So there's no wiring, you just slot it in. But if instead you solder these outer 2 rows, you can stick it in a permaproto and solder it up to your RP2040, which is a fair bit of work. Actually, I have to credit Lamore as co-author because she wired that up and did the RP2040 testing and code for that guide.
Right.
But it does work on both those platforms with CircuitPython.
Oh, very cool. Yeah, I'm looking forward to this. I got one of these boards and I knew I would be waiting for your guide before I bothered touching it. So
well, I can't wait to see what ideas you come up with. Then if we've got just a second more, I have a This Week I Learned. So this is a little servo motor from the Adafruit store with a gearbox in it. And the listing says it's a 20-to-1 gear ratio. And I wanted to measure exact revolutions. And I'm like, the math isn't working out. There's a bug in my program or whatever. So I learned after I took one apart and counted the teeth on the gears and like multiplied it all out. I'm like, because it's actually a ratio of 30,613 to 1,500.
Okay.
Or in nice round numbers, 20.4087 is the gear ratio. And so what I didn't know from my inexperience is usually those ratios that are listed for a gear motor are approximate and rounded. And I don't know. I mean, I understand why you wouldn't put that number 30613 to 1,500 in your product listing.
But it's a little rough if you hang your programming hat on.
I didn't know, and I thought I was going to measure exact revolutions
that's really,
for my purposes.
really interesting.
So if you run into this, it's not that you're crazy or there's something wrong with your gear motor. It's that they round it off just for simplicity's sake.
It's funny. I've been watching some of these videos of complex mechanisms built with Lego, mostly Lego Technics gears, and they're solving similar issues with Lego. But I'm curious what the ratios are really like, if those are what they advertise, because they usually have a
no. I mean, you have to have specific numbers of teeth. Like there's a number of these have a ratio of 12 to 22, no, 10 to 22, and it's like you're never going to get a round number out of that after you cascade some of them. So you just round it off and say, oh, it's 20 times.
Yeah.
And for like a
Thanks for sharing
RC car
that.
or something, that's fine.
Yeah.
Anyway, that's what I got. But check out my guide.
And so are you counting revolutions on this now, like with an encoder or something like that? Or were you trying to?
Yeah. So this particular motor, it has an encoder wheel on the back. And so you can actually count that with CircuitPython's rotary IO module.
Okay.
And so, I thought, it'll just be this number times that number will tell me my revolutions. And
I see.
No, not if you need it exact. If you need it within a couple percent, it's fine.
Very cool. All right. Well, thank you so much. And we'll go check out the guide too. Probably they'll show it in Ask an Engineer.
They probably will. And I will drop a link in the Discord chat.
Thanks so much. Take care. All right. Next up, we've got Anne. Hey, Anne.
Hi, JP. I've got a project that seems to have garnered a bit of interest. It's what looks like a floppy disk, but instead of a label here, like, maybe your average floppy, it's got a display. It's kind of shiny. There we go.
Oh, that's great.
It's blown out. It's got a bunch of file icons, and what that shows are the files that are actually on this device. Now, if you can kind of look, you can kind of see it's not quite the same as this. It's a 3D printed case by the excellent Ruiz brothers. And what I've done is put a Adafruit PyPortal display in here. And what that provides is the SAMD51 and the beautiful display, USB connectivity, and on the side here, there's a slot also for an SD card, but I don't have it quite coded up to use the SD card. But basically, you can use this as a smart thumb drive. It has 8 megabytes of built-in flash, and you can see the files, and you can scroll, you can touch and see the icons. So you can kind of scroll back and forth and see what's in there. And it has this kind of retro thing.
Yeah.
You know, you show your kids this and they go, wow, is that what it really was like? It's like, no, it's not what it really was like. You know,
in a future past that never existed, that was slightly chunkier and cooler.
Yeah. It will not fit into a 3.5-inch drive. Please don't try to do that. But it has a lot of retroness to it. It has the cool factor, and the project's very extensible. If you want like subdirectory peeking or SD card, it's all in CircuitPython, of course. So you can go in and do that. This case is beautiful. It has the detail in the back. It even has a little thing here where you can reset the board inside without having to open it all up and stuff.
I like those living hinge style button actuators that the Ruiz brothers use on those. Those are really smart.
They outdid themselves with this design.
I love it.
So the learning system guide is up right now. It was kind of a late edition today, and there's no soldering and low part count. You just get a Pi portal and a good USB cable. And then, if you're not up to 3D printing this, you can send it out to a service and then have it come in the mail, pop your board in, a little CircuitPython onto the CircuitPy drive. It's done.
That's great. And now, if I remember correctly, this was inspired by DinoRaptor Photoshop type of device.
DinoRaptor on Twitter. Her name's Dana Sabera.
Yeah,
I'm pronouncing that right. Her designs and some other kind of retro tech. Lamore was calling it 1980s, not with an 8, but with an A. This design where in this present, we look back on the past, and we think of design kind of not quite the way it really was. Dana's really good at picturing, like strange Macs and all kinds of things. It's wonderful. So this was inspired by hers and something she posted a while back and some other stuff. So kudos there.
Well, thanks so much for sharing that. And I look forward to checking out the guide, and I want to make one because that's super cool. Thanks, Ann. All right, next up, we've got Guy. Hey, hello.
Hello, how are you?
I'm doing well. What's new?
I made a clock that when it detects somebody looking at it, it shows the wrong time. It is so, yeah. So I didn't think of it as that sinister. I've been called evil all day on Twitter today, and I get it. I get it now. I should think harder about the projects I'm putting out into the world. But to make it slightly less evil, I changed it so that the wrong time that it shows is 11:11. So you have extra time to make wishes. So that's my
that's great. So it's whimsical now. It's no longer.
It's whimsical. It's not evil. It's not misinformation.
Love it.
It's whimsy. So you can see it kind of. I think it's picking up one of us right now, but you can see it switching back and forth between the real time. That's the real time, right? Yeah, that's real time. And then I'll try to put it right on my face. Sorry for working with the screen, but you can see it kind of thinking.
So you've got a bigger target there.
Oh yeah. All right. So I'll turn it so it'll show the real time, and then I'll put it on my face, and it'll show the wish time. There you go.
All right. Tell us about how'd you put this together?
Yeah. So I'm using mostly Adafruit stuff. I'll unplug it. So it's the ESP32S2 Cutie Pie going in stemma QT into the 7-segment LCD backpack, the I2C one. And then this is the person sensor it's like a new thing from company called Useful Sensors, which is a great name for a company.
Yeah.
And it is not going to focus in my webcam. There we go. But yeah, this is like a $10 module that you plug it in, and it immediately just like, you don't need to calibrate it. It just starts picking up faces. It has a
really
little
cool.
debug LED so you can see it. Yeah, and it just sends you over I2C. It sends you a bounding box of all the faces that it currently has in frame, which is really, really neat.
Oh, that's great.
It can also do identification, so you can calibrate it to, like, you can send it. You could say, okay, for the next frame, if you see a person, that's person number 1, and you can do that again for like 8 different people. And in theory, it'll be able to, like, when those people come back in.
Yeah.
Yeah.
Oh, that's really great.
Yeah, it's pretty awesome. It's, you know, I think they made a lot of trade-offs in terms of like keeping it really simple to use, but also making it, you know, like, that's a pretty powerful thing to have that small of an interface for.
Yeah.
I've been having a lot of fun with it, and I wrote the second part of this is that I wrote a CircuitPython library for it. They had done most of the work, so they had an example on their GitHub repo, but I just turned it into more of like a library format. They just had like a single script. I think, yeah, Todd's used it too. I saw his work with it as well. But I love this. Like, what a powerful thing with just 3 pieces, no soldering.
Really something.
It's amazing. So
really great. Nicely done.
It's on my GitHub. I meant to change my link below for my name to show where to find everything. That's my Twitter, and then you can find everything else. Follow that through. It's on my GitHub, both the library, which has examples for like calibrating and all the stuff, and then that code for this specific project.
Terrific. Well, thanks so much for bringing it by, Guy.
Yeah, no problem. Thank you.
See ya. All right, we just got a few minutes, so we're gonna speed round it with 3 people here. We'll start off with todbot. Hey, Todd.
Hey, all right. So quick, remember I had the Picotouch little, like, world's thinnest MIDI controller that I showed last time?
Yes.
Now I have a grid touch surface.
Oh, beautiful.
With LEDs, and it is also very, very thin. It's currently a little bit thicker because it's got the Pico on the back, but it's got MIDI out. It's got a little OLED on the front. Also.
Gorgeous.
It
yeah.
So yeah, I might have this in my Tindy store at some point in the future, but it's still a work in progress. I'm working on some jankiness of the matrix.
It's beautiful. It has a sort of very stylish calculator from the 80s look to it, or like a Timex Sinclair type of.
Totally.
Very cool. That's great.
Have a good night.
Thanks, Todd. All right. Next up, we got DJ Devon 3.
Hello. Yep, I got another little quick project. This one is a 3D printer bed calibrator PCB that I designed. It has a tiny little CR2032 coin cell. It's got an on-off switch. On-off. And then a leveling nozzle. So instead, this replaces a sheet of paper. Everyone's familiar with the sheet of paper and using that to calibrate or level or tram your 3D printer beds. Instead, this uses an electronic button, and this is based off the design by Chep from YouTube. So this is not like an original idea of mine, but I did take the idea and then added a gantry on this axis, and it just uses the same exact button. So like that, the electronic design is really, really simple, really basic. I just threw that together. And I wanted to show that off. And then of course I've got some pretty silk screen on the back, Betabrator, and this is available from this is available on the GitHub.
Great.
And then the PCB design is on Osh, Easy EDA, Osh, whatever that thing. But if you go to my GitHub, you can find a link to that.
Love it. So great design.
You can actually have these produced yourself fairly cheap, and then use that instead of paper. And then the way that you would use this is you would use your calipers and you would measure the thickness to the button, and then you would subtract that in order to get your Z offset. And there you go. Bob's your uncle.
Nicely done. Thank you so much for bringing that on and for sharing it.
You're very welcome. Thank you for having me. Everybody have a great night.
Take care. All right, last up. Hey, Michael, we've just got like a minute because Ask an Engineer is about to start. So sorry for running long on some of the others. What you got for us tonight?
Yeah, so I don't know if you remember, but like 6 months ago, I showed off a cool little FeatherWing I was working on. And I'm almost ready to release it as a product. And here it is, if it focuses. Yeah, so it's this little thing. I call it Display Plus. It's iSpy compatible, so it works with all the iSpy screens. Now, the reason why I call it Display Plus is because it's slightly different. I added 5 volts on one of the pins, but the screens don't need to use that pin. So I work around that. And then I also have this one for the Pico, the Raspberry Pi Pico, and I'm calling it a Pico Pal. So yeah, it works with both like basically any iSpy compatible display. There's a few, like 2 of them that are a little iffy, but it even works with a touchscreen one as well. So that's pretty awesome. And then I have a few different things too, like an LED on it. And yeah, I'll be launching this on Tindy in probably a week or 2. So
great. Yeah. What should people look for if they want to find that, find your Tindy store? I
haven't launched a product yet on there, but it will be called Prototype Delight. So, and I'm still working on the website and documentation and getting that all.
Those look great. Excellent work. Yeah. Thank you so much, and good luck with the launch.
Thank you.
All right. Take care. Okay. That is it for Show and Tell. Sorry, I ran a little long. Stay tuned for Ask an Engineer, which is happening 2 minutes ago. Bye.